Okay, I'm Michael Gammer from University of Cooperative Education, Berufsakademie Rhein-Main. I'm talking here about the usage of Mathematica to detect whether texts are possibly a plagiarism or not. This is me, this is Michael Gammer, or as you like to pronounce it, Gamer, it's okay for me, because of the results you will see here are the results of playing around formally with Mathematica with the new dataset feature. And I would like to explain you some things which you can use Mathematica 10 in detecting plagiarism. So I go over the abstract and just say 2 words. If you download this presentation, you have an abstract so you know what is going on. Detecting plagiarism is not ever so easy like it was in my last holiday last week in Portugal, where I saw this famous Pandora new jewelry originator priced with 18 euros. You can every buy for €2.50. It is simple to detect this is a plagiarism. It's not easy to detect this in the work of the students. I'm responsible for the business information science. For the Germans here, it is Wirtschaftsinformatik on a University of Cooperative Education nearby here in Rödemark. It's about 30 kilometers. It's a private university, and the students we have few students, it's 300, and 100 of them are studying business information science. And so I have all the work of the students in the direct access, and the idea was to fill this in version 9, new form dataset, and I filled in the work of the students in this dataset and then see what we can do. So I took all the works of the students. They have to write down 6 reports on their terms in the practical phase, as we call it. They are on a normal company working there and write down the report of about 2,500 words. And then finally, they have to write a bachelor thesis, which is 14,000 words. And they all have this text. And the idea is to fill this first in a data set. The structure of the data set is seen here. We have the year, the name, the group, and so on, and lastly, the text. We calculate a few indices here on this stored data, the rate of different words, the word length and the sentence length of the words in the text, and the sentence length of every sentence we have here, which gives an idea what we can do with this text. First observation is I have given on another talk in the IMS conference in Prague earlier this year in January, that we observe a decrease in the richness of the text written by the students. What you see here is one slide. It's the only slide you see twice if you have been in Prague, so you would like to recognize this slide. It is a development of the richness of the text over the last 5 years. We have, on the bachelor thesis, about 2 years, 3 years ago, the students used about 5,600 different words to write down their bachelor thesis, which is 14,000 words. You see a decline here in the last years. In the last 2 years, the average count of different words students used to write down the bachelor thesis is 3,600. So we have a dramatically decline here. And this is what we hear from the companies our students are, that they are not able to express precisely in written form. And this is a usage of the words. And when I discovered this in the last year and presented in January, the idea was born to do something like classify. We have now the text in the dataset. I have the text written from the students. And so we can try to identify the author of a bachelor thesis. This is the main idea. And there are a few obstacles. In Germany, something is very good, as I heard in the last days, and something is very complicated. Complicated is dealing with data. So we have very aware politics to restrict the use of data. I'm not able to use every data I have. I'm not allowed to use every data I have from the students. So one has to think about how we can classify this. The first one can do, one word to the code. The code is written not to be optimized for Mathematica, to use very few type strokes to get the result. It's optimized for readability. So it is not optimized for Mathematica. One can read it quite simple. And the first, what is done here, that I have a look on the sentence length of the bachelor theses and the written reports we have. What you see here is then this for one group. The groups are anonymized. I cannot give you here the real group names, nor you will see the real names of persons. We have something like person 1, person 2, person 3. In real, this is Fritz Müller, Karl Mayer, or so on, and the groups are vice versa. You see here in the first a large difference between the paper. It's a bit too large, I think. I make it a bit smaller. You have here the papers and the bachelor thesis, and you see a real difference. The first person on the left side uses an average sentence length of 15 words per sentence written in the reports, and the bachelor thesis, it has about 23. This is a part where we may have to do a closer look. You can do a nice bar chart with this, so you see it is here identified as, what is it, person 8, who has 47% longer sentences in the bachelor thesis than used before. This is suspicious, say. So we can make a look here. This is done without regarding, no classify, nothing like this, just the text, take the sentence length and compare it, and you have something you can think about. This has nothing to do with classify, this is done in the next steps. What we have what I have in the data set is this, group 1 to group 9. Group 9 is the youngest from last year, it's not much in it. The groups 1 to 5 are complete. I have the bachelor thesis and all the reports and the seminar papers. This is the set of data I have, it's about 10 megabytes. I can give you the presentation, this is no problem. You can download it, I think, from Wolfram. You can download it also from my homepage, which is given on the last slide, so stay tuned. And the text I cannot give away because these are confidential and regarding with problems in the companies, and so this is not possible. But you can have the code, it's no problem. The first attempt here is simple. The first I tried, given the text of the reports and given the bachelor thesis, so let's see what classify makes. I put this simply in, classify type. I've made a little function here. It doesn't matter how it is done, but you see the result on the last line, it's poor. We have a classifier function and the measurement, and you see we have an accuracy of 10%. This is not good. So using the whole data set is not the key. It is too large. You have 89 classes and lots of text, so this is too complicated. We can easily calculate the hits, by the way. This data set is transparent for the most functions, so the functions see through, so we have very fast the hits here, and we can now have 9 hits out of 89. This is a bad result. When we took not only the hits, but the top 5 hits, we have a 15 result, not a good ratio, but better. We can do so because a lot of students come from the same company, so the texts are similar. Yes, and this is expressed in this number here. If you classify a single group, results are much better. I've chosen here group 4, one of the first 5 groups where I have a bachelor thesis, and we have here 18 participants in this group. We have rather small groups. It's a private university, so I have a privilege to have small amount of people in my groups. 16 of this did a bachelor thesis, and if we do a classification here, we get a by far better result. We have an accuracy of 56% and an error of 43, and have 9 correctly classified students out of 16 who finished. This is by far better than using the whole group. We can visualize this. I can go a bit more quickly over this slide because we have seen something like this. This is a confusion matrix plot. You'll see the person names on the left, which the actual class, the predicted class, and then the main diagonal you see the hits where everything is fine. This is a nice feature from this classify the measurement functions. When we do a top 5 rating here, so we identify a person, original, and the top 5 of the class, we have a hit rate of 13. This is 13 out of 16 people, that's really good. So for me, as a corrector of this bachelor thesis, it could sound like this: look at these 3 theses which are not correct. Have there a closer look, because these may be suspicious. We have sometimes discussions with, yes, it is so, with how do you call it? It's a labor council of the companies, I think, where the students come from. What about the data? Are you allowed to do a hunt for plagiarism with electronic media? This is a maybe German-specific discussion, but we have this. And I'm not, in all cases, allowed to use the texts to identify the thesis, because the company says, no, this is confidential. You may read the text, but you are not allowed to process the text. It's funny, but it is so. It's not made from me. I was angry about that. So we can do a classification without the text. It is not so good like the text, sure, but it works. The first one can do is, here's a bit of code. We can look at it, but it's not necessary for now. The first what we do is to classify only using the rate of different word a person uses. This is rather specific for the works of the students written in the report form of 2,500 words, but we have here only one hit. This is clearly not possible to use, the rate. It is 2 words. Why is this so? Now, if you count the different words in a text, this rate decreases the longer the text is. If it is a rather short text of 2,500 words, we have about 44% different words in it. And if it is a bachelor thesis, we have about 30%. It decreases. Interesting, I said this also in Prague, you can make a nonlinear model and fit it, and you get a limit rate for each individual student or for each individual person. By the way, Thomas Mann has a higher rate of 20% than the Scientific American of the last 10 years. It has only 19% in the limit. But this is here the problem, that we cannot classify this by rate, because the bachelor thesis differs from the amount of words. You see this here. You have here again the papers and the bachelor thesis, and the different words in the bachelor thesis is by far higher than in the papers. So we cannot.
Am I allowed to ask a question?
Yeah, sure.
Do you have only the bachelor thesis and the scientific papers are in the same language?
Yes.
So it's not the problem that some scientific papers now, for example, in English, and they write their.
No. I have a few students which wrote their practical terms in English language, but up to now only one who wrote a bachelor thesis in English. But this is, I haven't put this in different bins up to now. You have this language, you can the language identify with the classifier, what language is this, whether it's German or whether it's English, but it doesn't count here. When you have only a rate of different words, it is a rate in German or in English, but it would be interesting to decide whether, or to analyze where the differences are. I was also asked in Prague of whether I have done some gender-specific investigation. I would have done if there are more women in my courses. I have only 3, so it is not valid to do any analysis here. The most are male in my students.
You mentioned earlier that the students are not in a situation to describe some things precisely.
Yeah.
And it might be sometimes that in your native language you are more familiar with.
Yes, sure. But this is always native language. They are all written in German. They should have been able to do this exactly, to be most precise. Now you see here, this is a great difference, so you cannot compare it. What we can do, we have a bachelor thesis of about 14,000 words, that's an amount, and we have the reports of 2,500 words. We can slide a window of 2,500 words length over the bachelor thesis and count the different words and make the mean. So we would get a more appropriate result. Doing this, we get the following. I show you the graphic, I think it's enough. We see it is more homogeneous. We have here the bachelor thesis smoothened around with this window and calculated the different words we have there. And if we do now the classification, we have a hit of 7. So the group has 16 people in it, and without knowing the text, only taking into account the rate of different words and the sliding window, we can identify 7 persons. This is not too bad. It's not good. I have a few minutes, I show you something better, but it is possible. This is a first attempt. One can make even here an improvement. We can put again not only the rate of the different words, but also the mean sentence length or the mean word length that people use. And then if you do so, I've done this with a few convenience functions for me that extract simply the data from the dataset. You see this here, ds build, dataset build makes a dataset with the raw data where you have your data and you have your classes, it's the full name of the student, and other functions simply extract these columns and make the classification, because it is not possible to work directly with classify on a dataset. So I have to extract them, but when you do it so, it's working fine. So if we do so, we have a bit better. We have 8 persons identified, former was 7. When we put apart the sentence length and the word length, we have a bit improvement, but it is still bad. This can be done if I am not allowed to use the words in the theses and in the reports. There are cases I'm not allowed. I regret that. But the things got. What you also can do is you can use histograms. You can make very simple a histogram of the words and the sentences in the bachelor thesis, and you have data, something shown like this here. The first 3 entries are shown 3 histograms and a number. The number is the rate of different words. The others are the histograms of the word length and the sentence length. And you can use this to identify persons. Again, you have a hit rate of 8. Okay. I'm not using the histograms. It is for time reasons. It took a lot of time to calculate here the classification. In the last slide, I will show you a diagram of the calculation times. It is here, if I have it right in mind, about 2 minutes. For these 16 people, 2 minutes. It's large. And if you have a word list, it is 0.2 seconds. So we may not discuss this. Looking on the next part, classifying with word lists, we are in a much more comfortable situation. So we have a list of words. We can extract the words, the whole thesis we have. So we have a direct access to the text of the thesis. And doing so, classifying the text, you see here a word list of a text. In this case, I extract all the words with multiplicity 3. This is the words the student used 3 times in his thesis or in his reports. I'll show you in soon, word lists with multiplicity 1, 2, 3, 4, 5, 6, 7, 8. So the number of words decreases and the accuracy increases. Here we have 8 correct. Again, confusion matrix plot with this. Okay, it's better. If we do the top 5 rating, we got the hits of 14 out of 16 people. This is quite good. Only 2 are misclassified if I do the top 5 rating here, and I have 2 theses which need a closer look to. This is a cumbersome task to have a closer look and hunting for plagiarism by hand. Okay, what we do next, I analyze the situation when I have word lists of varying length. When I have a word list with multiplicity 1, the word list is rather long, sure. I have the list of different words. Here 2 is a list of different words used twice by the student. You see that the computing time goes down. Sure, multiplicity 8 is only a few words the student uses 8 times in his thesis, and the accuracy goes down. You have here a graph showing this. If you have all the words are allowed to use all the words, to extract all the words, you have more than 80%. This is a good ratio. You have an error with about 18%, and 80% you are correct when using here the multiplicities. You can see it's also in the bar chart. You see, can you see it? It's 13. 13 is identified correct when I use simply the word list from the bachelor thesis and use this word list to classify the text. So I have a nice rate here to identify. What is funny, I've not in this presentation, if I take the word lists as the data I put in, there's the test data, the training data, sorry, and as the test data, the words the student uses 3 times in a bachelor thesis, I have better results. I don't know why. When I don't use the words in the bachelor thesis, but only the words they use at minimum 3 times, with multiplicity 3, I got here 14 and not 13. I have no idea why, but it is so. If you look at the word count here, in the first case, we have a very, very bad accuracy. You see this in this map, in this graphic here. We have an accuracy with its, should be this accuracy of about 40% with multiplicity 8. It is not good, but if you take into account that we have this 40% with only analyzing 65 words out of 2,500, this is not too bad. I was very surprised by this, that it is possible to do so. 65 words is not much. It's a few lines extracted from the theses, and you are able to, with a 40% probability, you are able to say, okay, this guy has written it. And if you take the whole word list, it is 438. You have only to extract 438 words, the different words, and you have an 87% accuracy in identifying the person who has written the thesis. This is a great result for me, because when I'm allowed to use this text, I do a pre-processing, and I have then 3 or 4 negative hits, say so, 3 or 4 theses where I have to take a closer look, which are suspicious. The length list, this is an average number. Oh yes, I should mention this. This is an average number, 438. The maximum here is easily calculated, is 621. So the student with the richest words uses in 621 different words to write down a 2,500 word long report. Now one can discuss whether this is good or whether it's bad, but it's a fact. Looking at the time, we get an overview here, result for group-wise classifying. This is the timing here on the left side of this coupled bar chart, and word list of length 3 has a hit rate of 87.5%, and the computing time, this is difficult here, it's so small, of 0.2 seconds. And the histogram I mentioned, here we have 31% accuracy. This is not too good, but we have a computation time for nearly 2 minutes. So the best one can do is to make a word list. The classifier used here automatically by Mathematica is a Markov, and it's really lightning fast. 0.2 seconds is good. A histogram, there are different methods used from Mathematica automatically, and maybe this is the time-consuming part here. The others are also rather fast. You can use, it's the best, the worst is 5.29 seconds, so it's very good results, and they have 81% accuracy. Yeah. Okay, that's for the point. Thank you for your attention. Now, if time to questions, here are the contacts. You can see the presentation soon on my website, and surely also in Wolfram Research. Thank you.